Bonjour. Welcome to Wahsa Distance Education Center's radio classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate.
If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You're always welcome to join me live through the Zoom link, which is available both for me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 until 3 in the afternoon. And we are now in our 9th and final week of our 9-week course. You definitely should know what you need to submit by now, but as always, just to remind you, the support questions, the ones with the little pencil icon, are not for marking. These are practice problems. So you decide which ones and how many to do. If you're understanding a concept, feel free to skip questions. You do what's best for you. If you need more practice, let me know and I can send you more. The answers are at the back of your booklets, so please check your work to make sure you're on the right track. The key questions are the ones with the little key icon, and these are the ones to submit for marking. So please do all of these questions, showing all of your work, your steps in your thinking. This way I can understand what it is that you understand, and if you're struggling with anything, I can give you part marks and figure out how I can support you to understand. So how do you submit your work for marking? Well, there's 3 ways. The first way is to scan and send your work in electronically. If you have a device, a smart device, you can either scan it through an Apple device with the Notes app, or Android devices have a Google Drive app. These are free apps that generally come with these devices and are fairly straightforward to scan. If you'd like to learn how to scan your work to make your files slightly smaller and easier to manage, I have tech tutorials on my YouTube channel, which will walk you through step-by-step how to do this. Then you can send it to me through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location at 74 Front Street, with a bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732, or toll-free fax to 1-800-463-7852. Sometimes when things get faxed here, they get lost in the shuffle. I'm not sure exactly how, but it's always a good idea when you send a fax. If students decide to send a fax, that's fine. Just send me an email or call me or something to let me know that you've sent it, so that we make sure that we find it. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. So you can find me on Facebook and subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our videos. All of our radio Zoom classes are recorded, and I post them to YouTube shortly after airing. Also on my YouTube channel, there are short videos that explain common errors and confusing concepts. So this is a really good place to go if you are struggling with something and you need a little bit of support and you can't get a hold of me, it's outside of my working hours or something like that. It's a good place to go first before doing a general online search, just because it narrows things down already. Math is a really visual subject, so I strongly encourage you to access the videos, either joining me live through Zoom, though you may not talk to me, that's fine. Just watching is totally fine. Or watching the replays on YouTube is really going to set you up for the most success. If you can't access either of those because you don't have reliable internet or something like that, let me know and I'm happy to send you a copy of the videos so you get the full experience. All right, if you have any questions or concerns, please contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook, again, is B. Slate Wahsa. Call me at the office at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m.
And we are reviewing Unit 4. So first, let's do a brain activation with mental math. We know that mad minutes that many of us experienced in elementary school are not beneficial. They don't really actually teach us how to be more comfortable with numbers or be confident with our arithmetic facts. So instead of drilling and killing, we focus on developing strategies that we can apply to various situations that we're comfortable with and the applications. So today's question is 63 divided by 7. And we're using the strategy of shared groups. So often when we're first learning about division, we sort of make, we make 7 groups and we share it out one by one by one by one until we run out. We could do that, but I'm also going to think about, well, if we shared, instead of doing by ones, we can do them in other friendlier numbers. So 7, I'm going to think of as the 2 numbers of 5 plus 2. So if I have 63 things and I want to share them in groups of 7 and see how many groups I have, I'm going to say, okay, well, if I do 5 a bunch of times, sharing out 5, so 10, 15, 20, 25, 30, 35, 40. So I've done 8 groups and I've shared out 40 of my things so far. So I still have 23 to go. So I'm going to say, okay, well, I think another group, I could have 2 more groups of 5. So now I have 50. And now I'm going to share out 2s as well. So for each of my 5s, I'm putting a 2 because then that really means that I have 7, right? So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, plus 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I had 15 plus 20 is equal to 70. So I've gone over because that's too many groups. So I'm going to take away this one group of 7. And so then I'm going to, that's not going to work if I do that. Oh yeah, that group 7, I don't need to share it. That's just 2 more than I have. So if I take away that group of 7, now I have 63. So sharing, that means I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 63 divided by 7 is 9. And there we go. That's how we can do it with shared groups of more than just 1. All right, let's quickly remember what the final assessment is going to look like and what to expect. So it's not an exam due to COVID-19. We are not expecting students to get to learning centers and be supervised for an exam. It's just not realistic. So we're doing a culminating assignment instead this term. So it still covers all 20 of your lessons. It covers all of the course material, but it's open book. So you can have access to your assignments, the YouTube videos that I posted, as well as any other YouTube videos that might be useful for you, your IELTS booklet with the instructions in there, as well as your Desmos and virtual manipulatives. So you can use the online tools that we've used throughout the course. So with common activity, you have access to all of those things and any other resources or materials that you'd like to oppose to an exam, which you wouldn't. All right, so it's not timed, but it will have a deadline. So you don't have to just have, it's not like I give it to you and you have it for a day. You will have like 2 weeks or so, roughly, give or take. We can negotiate that depending on the situation to do the full assignment. And the structure will be slightly unfamiliar. It's just not going to be a list of questions. You're going to have to do a bit of critical thinking and application to figure out how to complete the project. So it's not, just to be aware that it is something that will be slightly different, but you're still totally going to be able to do it if you've worked through all the 20 lessons. All right, so let's review our Unit 4, our last review today. And let's start with lesson 16, which is sampling data. So we needed to remember particularly some statistical vocabulary of population and sample. So population being the whole and sample being a small part that represents the whole. And then we had 6 types of sampling. So we had simple random sampling, systematic sampling, cluster sampling, stratified sampling, convenience sampling, and voluntary sampling. And those all are done in slightly different ways in order to hopefully represent your population as a whole. If you don't remember exactly how all of those samplings worked, go back to lesson 16 and check that out again in terms of getting in further detail. Quickly, random sampling, you just randomly pick a bunch of people. Systematic sampling, you assign everyone a number, and then every certain number, you, like every 6th person or 10th person or 20th person or whatever, you would take that person. Cluster sampling is that you put people in groups and then you put based on some sort of criteria, and then you pick entire groups out of all of the groups instead of picking individual people. Stratified sampling, you put people in groups based on the their demographics out of the total population, and then you pick based on a proportional representation of those of your population. So it's not random. The individuals you pick are random, but you pick if there are one group of people who have a similarity and there are more of them than another group of people, then you pick more of those people than the other group. Convenient sampling is you're just connecting with people who are easy to access. And voluntary sampling or self-selected are people select themselves, they volunteer to be sampled. All right, so let's do some practice questions. Determine the best sampling method for each survey. A, the school newspaper wants to determine which presidential candidate in the upcoming student council election is supported by the majority of students. As always with these things, there might be more than one answer that makes sense. Basically, you just need to justify, you need to explain why you believe that would work. So for me, being in a school, I would think stratified would be a good idea, because then you can use with by grade, because then you're going to get representation across all of the grades in a school. And if there are more grade 9 students there, you hear more from them, opposed to say if there are less and less grade 12 students. All right, B, a light bulb manufacturer wants to determine the lifespan of a certain type of light bulbs in hours. So for this, I would say systematic. So having some sort of system, every certain number of light bulb would be tested. So instead of just testing all of them in one batch, you would test out throughout all, but you don't have to test every single one. All right, C, the parent-teacher association wants to determine the average number of hours per week that students spend on homework. So again, this could be stratified because it could be by grade, or it also could just be random sampling to just get a random bunch. Either could work. And D, the producers of Rock Idol want to determine which of the 2 remaining candidates should be the next Rock Idol. So this would be self-selected, because only the people who want to are going to volunteer that information. They're only going to call in if they're going to volunteer themselves to do that. Okay. All right, lesson 17, measures of central tendency and standard deviation. So to remember what we went through for this lesson, for central tendency, we have the mean, which is when so these are the averages of your data. So to find the mean, you add up all of your data points and you divide by the total number of data points. The median, you order your data points from lowest to highest and you find the middle value of your data set. If you have 2 middle values, then you add those 2 up and divide by 2 to find what's exactly between those 2 middle values. Your mode, find the value that is most frequent, and it is possible to have more than one mode if you have more than one value that has the same frequency that is the highest. And then looking at measures of variability. So we had our range, which is the difference between the lowest and the highest value. So seeing how much data ranges is what we would say. So how much is spread out. But their outliers would really distort the accuracy of this information. So if you have a really, really high value or a really, really low value, that's just going to skew your information, because if everything else is clustered together, but you have that one piece of information really far away, the range doesn't tell you that the information is clustered together. And we have your variance, which measures how far data points are spread out from the set of data compared to the mean. So this takes into account that this means that outliers don't affect it quite as much. Your variance is in squared units, so it is going to be usually much larger than your data. And to find it, it is the sum of the squares of data points distance from the mean divided by the number of data points minus 1. Totally a hard thing to just hear and understand. If you're unsure about variance, go back to the lessons about lesson 17. There are 2 videos about lesson 17, one about measures of central tendency and one about standard deviation and measures of variance or variability. So go back and check that out if you're unsure. And then standard deviation is the typical amount the data points differ from the mean. And this one has the same units as the original data, so it's going to be the same size, so a little bit easier to understand for most of us. And it is the square root of the variance. So you need to find the variance and then take the square root to find the standard deviation. All right, so let's do some practice problems and find some of that information. So we have a data set, and we're going to find the mean of the above data set. So we're going to add up all of our points and divide by the total number of them. I'm not going to write out that I'm adding them all up. I'm just going to do that on my calculator in order to save some time and space. So these are the points that we're adding up. 4.2 plus 11.5 plus 6.8 plus 5.2 plus 5.4 plus 6.3 plus 12.1 plus 11.5 plus 11.9 plus 7.8 plus 13.1 plus 5.8 plus 6.2. Okay, so that equals 107.8. So to find our mean, we need to do 107.8 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 107.8 divided by 13 is 8.29, so 8.3. So our mean is 8.3. Okay, so then part B, find the median of the above data set. So we need to organize our information from lowest to highest, which can be annoying, but we need to do it. So we go back and we look at our data. So 4.2 is our smallest, and then I'm going to cross it off so that I know that I did it. Then I've got 5.2, 5.4, 5.8. So my next is going to be 0.2, and then 5.4, and then 5.8 are my next lowest. And then I need to look, and I have a 6.8, and I have a 6.3, so that's lower. 7 and a 6.2, so 6.2 is next, and then 6.3, and then 6.8. And then I have a 7.8. And then I don't have any 8s or 9s or 10s. So then I have 11.5 twice, 11.5, 11.5, and 11.9, and then 12.1 and 13.1. So this isn't my favorite, but it's, you gotta do what you gotta do. So then to find the mean, yeah, I got all of them. Always good to check. So find the median, we need to, we've ordered our data, and now we need to find the middle amount. So you can cross off from the top and the bottom. You could also say, okay, I know that there's 13, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So half of 13 is 6.5. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So we can see that our middle value is 8.6. Sorry, not 8.6, 6.8. My bad. So the median equals 6.8. And then the mode for the set is the most frequent. Well, we've just ordered them, which is helpful because then we can see if there's any ones that happen more than once. And 11.5 is the mode because it happens twice and everything else just happens once. So here for this set of data, our mean, median, and mode are really very different. They are not, sometimes they can be really close together. And here our mean is 8.3, our median is 6.8, and our mode is 11.5. So that's fairly different. Yeah. Okay, so then continuing for the same data set, part D, find range for the data set. So remember, our range is we're going to take our lowest and our highest. So we're going to go back and see our lowest was 4.2 and our highest was 13.1. So we're going to do 13.1 take away 4.2, and 13.1 take away 4.2 is 8.9. So we have quite a range of data. And now we need to find the variance. So I have this chart, I put this chart in to help organize our information, which can be really helpful. So I've listed all of our data, and then we need to find, well, the mean we know. The mean is 8.3. So the mean is the same for all of these, right, all the way down. And now the difference from the mean, we need to subtract. I'm just going to do this on my calculator in my hand instead of changing screens. So 4.2 take away 8.3 equals negative 4.1. 11.5 take away 8.3 equals 3.2. 6.8 take away 8.3 equals negative 1.5. 5.2 take away 8.3 equals negative 3.1. 5.4 take away 8.3 equals negative 2.9. 6.3 take away 8.3 is going to be negative 2. 12.1 take away 8.3 equals 3.8. 11.5 take away 8.3 equals 3.2. 11.9 take away 8.3 equals 3.6. 7.8 take away 8.3 equals negative 0.5. 13.1 take away 8.3 equals 4.8. 8.5 take away 8.3, sorry, 5.8 take away 8.3 equals negative 2.5. And 6.2 take away 8.3 equals negative 2.1. So then you can go through, and if you wanted to, you could fill in this square difference chart. So then you could square each of these values and write those down. What I'm going to do is I am just going to add them up, because then after we square them all, then we need to add them up. And I'm just going to do that all in one step, again, to save time. I'm sorry that I'm constantly trying to save time. It's because I am always trying to squish in more than we probably have time for, but there's lots to learn. So I'm putting in the difference from the mean for each of my points and squaring it. So I have negative 4.1 squared plus 3.2 squared plus negative 1.5 squared plus negative 3.1 squared plus negative 2.9 squared plus negative 2 squared plus 3.8 squared plus 3.2 squared plus 3.6 squared plus negative 0.5 squared plus 4.8. Sorry, that didn't go in right. 0.8 squared plus negative 2.5 squared plus negative 2.1 squared. Okay, so that gives us 122.91. So 122.91 is, and then we need to divide that by our total number of points, 13, take away 1. So we need to divide that by 12. I think I just closed my calculator because I wasn't thinking. So let's get that calculator back up. Okay, so we have 122.91 divided by 12 equals 10.24, so 10.2. So our variance is equal to 10.2. And that means our standard deviation is equal to the square root of 10.2. So the square root of 10.2 is equal to 3.19, so 3.2. So our data varies by 3.2 units in total. So there we go. Okay, lesson number 18, data distributions. So data distributions, we were looking at histograms, and a reminder that histograms are like bar graphs, but the bars are touching because the data is continuous. So there's no gaps unless you don't have any information about those particular data points. So it shows data frequency in intervals opposed to individual units usually. Then we have different ways to analyze these distributions. So we have a normal distribution, which is a symmetrical distribution around the mean. So the mean is equal to the median, which is equal to the mode, and all of our data falls away on either side of that point. Our bimodal distribution means that we have two peaks. So we have two modes, two pieces that are of higher frequency. We have a left skewed distribution, which we have the tail is on the left side and the peak is on the right side. So that's opposite of the way that my brain wants to work. So it's important to remember. And here the mean is less than the median, which is less than the mode. And then we have right skew distribution where our tail is on the right side and our peak is on the left side. And here our mean is greater than our median, which is greater than our mode. All right, so let's look at a practice problem here. Number 3, the winning Super Bowl scores from 2000 to 2022 are listed below. I've got a list of scores. We need to create a frequency table for this data. So I'm looking at my scores for these 22 years, and I need to think about what are going to be useful intervals. So they looks like 17 is maybe my lowest. Yep, so 17 is my lowest. And then it looks like I have a 48. 48 looks like it's my highest. So I'm going to track my information, I'm going to make intervals. I'm going to start with 0, even though I don't have a score of 0. But so my first one is going to be 0 to, let's say 6, and then 7 to 13, and then 14 to 20, and then 21 to 27, and then 28 to 34, and then 35 to 41, and 42 to 48. So I'm going, my intervals should each be of 6. Yep, okay. And that should include all of my data. So then we're going to go and we're going to tally our intervals, our data points. So we go and we say, okay, 23, I'm going to cross it off because I'm going to tally it. And so that goes into 21 to 27. 24 goes into 21 to 27. 20 goes into 14 to 20. 48 goes into 42 to 48. 32, it goes from 28 to 34. 24 goes from 21 to 27. 21 goes into 21 to 27. 29 goes into 28 to 34. 17 goes into 14 to 20. 27 goes into 21 to 24, or sorry, 27. 31 goes into 28 to 34. Another 31 goes into 28 to 34. 21 goes into 21 to 27. 34 goes into 28 to 34. 43 goes into 42 to 48. 28 goes into 28 to 34. 24 goes into 21 to 27. 34 goes into 28 to 34. 41 goes into 35 to 41. 13, oh, I missed that one before, but that's okay. 7 to 13. 31 goes into 28 to 34. Another 31 goes into 28 to 34, and 23 goes into 21 to 27. So now I've done all of my data points, and now I tally them. So now we're on the frequency. So 0 to 6, there's 0. 7 to 13 is 1. 14 to 20 is 2. 21 to 27 is 8. 28 to 34 is 9. 35 to 41 is 1. And 42 to 48 is 2. Okay, so then now we've created a frequency table. And now we're going to create a histogram with this data. So we need to, so on our horizontal axis is going to be our scores, and our vertical axis is going to be the frequency. So on our scores, so we're going to go from 0 to, I'm going to write 7 because between 0 and 6 is right before 7, and then 14, and then 21, and 28, and 35, and 42, and 49. So then our frequencies are 0s at the bottom, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we now need to go back and look at our table. So from 0 to 6, we had a frequency of 0. From 7 to 13, we had a frequency of 1. So between here, from 7 to 14, because is a frequency of 1. Then from 14 to 20 is 2. And from the next one, 21 to 27 is 8. So we have the next bar is going to go up to 2. And the third bar goes all the way up to 8. As you can see, we all know that my drawings are beautiful. Then we have the last 3 intervals are 9, 1, and 2. So the next one is up to 9. And 2. So then we've created a histogram, a beautiful histogram. Okay, and then identify the distribution type. So I'm going to just try to see if I can draw a line. Sort of shows what's going on. Looks kind of like that. So I feel kind of like it's a normal distribution, even though we have most, like it's really, really high in the middle. And the other 2 sides fall away. But I feel like it's a normal distribution, makes the most sense, because it's not skewed to the left or to the right, and it's definitely not bimodal. So it's not uniform. They're not all the same. So normal is what makes the most sense. All right, lesson 19, theoretical probability. So what the terminology to remember is that probability, successful result, trial, sample space, outcome, and event are all important words to know what they mean. And the theoretical probability is found by the number of desired outcomes divided by the total number of possible outcomes. So remember, experiential probability, we'd actually do an experiment, but theoretical probability, we're just doing it, we're wondering what in theory. So how many are successes could we have? What is the total possible successes divided by the total possible all the outcomes? And we also learned about tree diagrams, that display all the events by using one branch for each possible outcome, including the probability. And here's an example of flipping 2 coins, showing the branches of you could either have heads or tails on your first flip. And then after having heads or tails, you could either have heads or tails for each of those, depending on whatever you got on the first one. The second one, you still have 2 options. So then calculating the probability, we would do that. We determine the probability of multiple events by multiplying the individual probabilities of the events happening. So let's look at some examples. So number 4, when drawing from a deck of cards, what is the probability of drawing a face card and then an even numbered card? You replace the card after drawing the face card. Write your answer as a percent rounded to 1 decimal place. So to find the probability of drawing a face card and then drawing an even number is equal to the probability of a face card times the probability of an even number. So the probability of drawing a face card. So there are Jack, Queen, and King are the face cards. And there are 4 suits, spades, clubs, diamonds, and hearts. So there are 12, 3 times 4, 12 face cards out of a total of 52 cards. And then we put that card back in the deck so that we still have a total of 52 cards. And now what is the probability of drawing an even number? So the even numbers are 2, 4, 6, 8, 10. So there are 5 for each suit, and then there's 4 suits. So there's 40. So because they want us to be a percentage, we can do our division first. We can either multiply the fractions or we can do our division first. Either way, we're going to get the same answer. So what I'm going to do, clear 12 divided by 52 is equal to 0.23076. So I'm going to say 0.2308. 0.2308 times, and then 40 divided by 52 is equal to 0.7692. So 0.7692. So then if I multiply them together, I get 0.2308 times 0.7692 equals 0.1775. So 0.1775. The question says to write my answer as a percent, rounded to one decimal place. So that means that I times this by 100 to get a percent. So that's 17.75. And then rounded to one decimal place would be 17.8% would be right of the probability. All right, number 5, you and your friend Floyd are driving to Montreal to see a concert. You decide to flip a coin 3 times to decide who will pay for gas. Floyd says that he will pay if the coin lands on 3 of a kind, for example, 3 heads or 3 tails, and you can pay otherwise. Use a tree diagram to display all the possible results of flipping a coin 3 times. So for our first flip, we have the options of heads or tails, and our percentage chance is 0.5. Then our flip 2, we either have heads or tails. And flip 3, we have heads or tails, heads or tails, heads or tails, and heads or tails. Okay, so that's what a tree diagram would look like. Expresses a percent the probability of getting 2 heads. So we're going to go back and we're going to look and we're going to say, okay, we want to have 2 heads. So, oh, and each of these are 0.5. Sorry, I forgot to write that out, but each of them are 0.5. So the ways that we could have a head, 2 heads, so not the first way. So 1, 2, 3. So there are 3 ways, and our total number of ways is 1, 2, 3, 4, 5, 6, 7, 8. So there are 3 out of 8, which is equal to 3 divided by 8 is equal to 0.375, so 37.5%. Okay, so then what's the probability of getting at least 2 tails? So go back to our tree diagram. And so we have at least 2 tails. So 3 heads is not going to be 2 tails. 2 heads and a tail is not 3 tails. Sorry, at least 2 tails, right? At least 2 tails. So heads and 2 tails is 1, so that's 1 way. Tails and 2 heads, tails, head, tail, that's 2 ways. Tails, tails, head, that's 3 ways. Tails, 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 that's 4 ways. So at least 2 tails is equal to 4 out of 8, which is equal to 50%. 3 of a kind. So we have heads, heads, heads is 1 way, and tails, tails, tails is another way. So we only have 2 ways that we get a 3 of a kind. So we have 2 out of 8, which is equal to 25% of the time. So then part C is this a fair way to decide who will pay for gas? Explain. So Floyd pays for gas. The chance of Floyd paying for gas is 25% of the time, because there's only 2 ways that it could be 3 of a kind. That means that you are likely to pay gas. Probability of you paying gas is 75% of the time. So I would say this is not fair based on that, because it is not an equal opportunity. Most likely you are going to be paying for gas. Oh, sorry, this is not fair. I forgot the word not. Okay. All right, and lesson 20, probability and statistics in the media. So with probability and statistics in the media, we talked about how statistics can be a powerful way of communicating information. that they can make things clearer and more accessible to understand if we have statistics, but they can also be incredibly misleading. So it's essential to think critically about the information that's presented to us by the media so that we can understand if things are missing or if we're getting the whole picture. So let's look at a question. Number 6, many people jump to conclusions after reading headlines. The two below headlines are based on the same set of data from Global Web Index Research Report into social media trends over the last year. So what do we notice? So let's look at these two headlines. So headline A is 98% of digital consumers are social media users. And headline B is almost half of Brits have reduced time spent on social media. So headline A makes me think 98% of digital consumers are social media users. Makes me think that lots of people use social media. That's what that makes me think. So if I was going to advertise, I might do advertising on social media. If I was going to be concerned about social media use and messages that are being displayed there, I would be concerned that a lot of people are being affected by that. But that's what that headline makes me think of. So headline B, almost half of Brits have reduced time spent on social media, makes me think that people are using social media less. That's what that headline makes me think. So when I look at these two together, I think lots of people are using social media and people are using social media less. They don't really line up. I mean, I guess that can be true that lots of people do use social media and yet they're still using it less. But that's not, when I read one of these, that's not the feeling that I get. I get sort of polar opposite feelings. So let's look at some of the data. So it's true that the majority of digital consumers are social media users, but when we look at the actual data, what do we notice? So if instead of just reading headlines, but looking at the data, we can see that by age, it is really, really different. So if you are 16 to 24, on average, you're on social media 3 hours a day. Whereas if your age is 55 to 64, you're on average on social media 1 hour a day. So it really depends on your age. If you're using, by how much social media you're consuming or you're being part of. So that is a really different picture in terms of who this stat represents. And then part C, how does the information below contradict the former graph? So what information is missing? So below what I have on the screen is 41% of Brits say they've decreased time spent on social media networks over the last 12 months compared to 46% of Americans. So we have Twitter, Instagram, I don't even know what IN is, Pinterest, and Facebook. That makes me think of like linked, but that's not social media. So maybe it is for business. Anyway, sorry. Many have deactivated their accounts. Reasons for doing so include 30% are no longer interested in what other people do share. 26% say social become too shallow, personal, image driven. 25% didn't trust social media companies with data content. 24% didn't like being dependent on social media. 23% wanted to spend more time with family and friends. So this is all talking about how social media, how people have decreased and why. But when we look back at the previous graph that's talking about ages, well, is this a decrease? We don't know if by age group are these numbers decreases. So in terms of 16 to 24 age group, they're at 3 hours a day on average. Is that a decrease, or are they not decreasing at all? Is it a decrease at different age categories? And what does that mean overall? So having these two sort of separate pieces of information don't really give us the whole picture, and we can't make assumptions. We can't assume that who these percentages of decrease, who that is applying to. Are they, yeah, we don't know enough information to really make that meaningful. So that's what statistics is. You really just need to be asking yourself what information is missing, what assumptions are you making, and what who's the information benefiting? So if they're giving you some sort of information, who really benefits from there being missing information or from not getting the whole picture? And why might that be the target, or why might that be the choice of whoever is giving you that information? So you just really need to look critically. There isn't necessarily a exact right way or right steps to do, but you need to be thinking critically in order to really understand what is going on when we use statistics and probability in the media.
Okay, and that is our intense review of Unit 1. Again, we just blew through it. It was a lot of information. So if you have any questions or you're unsure about anything, you need to review anything more, obviously you should review things more. Go and check out our YouTube channel that is B Slate Wahsa. There's a playlist called MBF3C. All of our lessons are there, so you can go review at a slower pace. Today was just a pack it all in and remember what we've done this year. If you have any questions, give me a call at 807-737-1488, extension 2209, or call me toll free at 1-800-667-3703. Send me email at bronwyn.slate@nnec.on.ca, or a Facebook message at bslatewahsa. My office hours are Monday through Friday, 9 a.m. to 3 p.m., although I teach the last hour of my day, so that is not a good time to try to get a hold of me. If you, as always, please reach out. I'm here to support you. That is my job. Thank you so much for joining me. I hope you have a great day. Miigwech.